Today, let us begin with a new topic, the sampling distributions. Okay, so that firstly we consider the population. Population means in statistics, population means the aggregate of objects under study. That is, the aggregate of objects under study in any particular matter is called a population, and a sample is any finite subset of population selected from it with the objective of investigating its properties. Any finite subset of population selected from the population with the objective of investigating its properties is called a sample, and the number of units in the sample is called its size, that is the sample size. Sampling is a tool which enables to draw conclusions about the population characteristics after studying the items that are included in the sample. That is, finally, we have to draw the conclusions about the population, which is known as statistical inference. Okay, statistical inference deals with estimating the properties of the population parameters and testing of hypothesis. So that sampling distribution is a very important subject in statistics. Okay, so that sampling, we consider a sample taken from the population in order to study the characteristics of the population, and there are many methods for selecting a sample from the population, and the selection of sample based on the theory of probability is called a random sample. The selection of sample based on the theory of probability is called a random sampling, and such a sample is called a random sample. Simple random sample is a sample selected from a population in such a way that every member in the population has an equal and independent chance of being selected in the sample. Once again, simple random sample is a sample such that every member in the population has an equal and independent chance of being selected in the sample. So let us consider a random sample. That is, whenever we speak about a random sample x1, x2, etc., xn from a population, we assume all the variables x1, x2, etc., xn are random in nature, and all the variables are NIID random variables. Let me write that as, if x1, x2, etc., xn random sample, if x1, x2, etc., xn is a random sample taken from a population, all xi from a population, xi I equal to 1 to n, or NIID I equal to 1 to n, or NIID random variables. IID means independent and identically distributed. Independent and identically distributed. Identically distributed, IID, okay, independent and identically distributed random variables, IID random variables. That is, when x1, x2, etc. xn is a random sample taken from a population xi I equal to 1 to n or n IID random variables, that is all the random variables xi's are independent and identically distributed. That means all the random variables has the same probability function of the population, same mean, same variance, etc. Okay, this is a random sample taken from the population. Now, when we speak about the sampling distributions, we have to consider the two concepts, the parameter and statistic. Any statistical measure about the population is called a parameter. That is, any statistical measurements, the mean, the variance, the moments, etc. about the population means by considering all the units of the population, such a measure is called a parameter. And any statistical measure, that is all these measures such as mean, variance, etc. Based upon the sample data is called a statistic. Any statistical measure about the population, parameter. Okay. Any statistical measure about the population, is called a parameter. Example, population mean. Usually represented as mu. Population variance as sigma square. Very important. We express the population mean as mu and the population variance as sigma square. Then statistic means any measurable function of sample observations. Statistic. Any measurable function of sample observations. That is, any statistical measure based upon the sample is called statistic, sample observations. Okay. For example, sample mean. Sample mean is usually represented as x bar and sample variance s square. Sample variance, we write it as small a square. So this is the difference between the population, the parameter and the statistic. Any statistical measure based upon the population as a whole is considered as the population parameter, and it will be usually unknown, and we can obtain the estimate of the population mean by means of the sample taken from the population mean. So that it is represented as sample mean x bar and sample, and whenever we consider x1, x2, etc. xn as a random sample, we can obtain the sample mean as equal to x bar equal to, let me write, x bar, the sample mean is obtained as x bar equal to sample mean equal to, whenever we consider a random sample or a sample x1, x2, etc. xn by means of this sample, sample mean x bar is defined as equal to 1 by n sigma I equal to 1 to n xi. The basic concept is the mean is obtained by taking the sum divided by the number of observations. And the sample variance is square equal to small a square, we write it as, and equal to 1 by n sigma I equal to 1 to n xi minus x bar whole square. The variance is defined as the mean of the square deviations of observations taken from the arithmetic mean, and can be simplified as 1 by n sigma xi square minus x bar square. So these two functions can be represented as the sample statistics x bar and variance s square. Okay, now we consider the concept of sampling distribution of a statistic. Sampling distribution of a statistic. That is, we have a population and we have a sample taken from the population. Let us suppose the population has a size equal to capital N and we consider fixed sample size equal to small n. Then we can draw NCN samples or NCN samples taken from the population. All these samples can be studied and we can obtain the statistic, that is the functions sample mean, sample variance, etc. for these samples. For example, if we consider the sample means for these NCN samples, we can obtain such a large collection of sample mean values, and hence the probability distribution of the sample mean is called the sampling distribution of the sample mean. Okay, that is the probability distribution of the sample mean values is a very large in number, so that it is called of the same size n. It is called the sampling distribution of the sample statistics, the sample mean, sampling distribution of the sample mean. So, whenever we consider a random sample x1, x2, etc., xn of size n from a population, that is, let me write let x1, x2, etc., xn be a random sample of size n taken from a population. Then the sample mean x bar equal to, sample mean x bar is, I have already defined that, it is equal to 1 by n sigma I equal to 1 to n xi. Okay, then the sampling distribution of the sample mean. Sampling distribution of sample mean. That is, x bar follows normal mu with mean mu and variance sigma square by n for large sample. X bar follows normal with mean mu and variance sigma square by n for large sample. Okay, that is, whenever we consider a large sample, we have the sampling distribution of x bar is normal. Whatever the population is under consideration, the sampling distribution of the sample mean x bar is normal with mean mu and variance sigma square by n, which is obtained by the central limit theorem. The central limit theorem states that for a large sample, if x1, x2, etc., xn is a large sample taken from a population with mean mu and variance sigma square, which is finite, mean mu and variance sigma square, Sn equal to sigma I equal to 1 to n xi, central limit theorem. Sn equal to sigma I equal to 1 to n xi is asymptotically normal, that is tends to normal with mean equal to n mu and variance equal to n sigma square for large n. That is, as n tends to infinity for large n means, for large sample size, the central limit theorem states that the sum of these random variables is asymptotically normal with mean n mu and variance n sigma square. That is, we can write x bar as equal to Sn by n. X bar, and hence we can write x bar, the sum divided by the number of observations, as equal to x bar equal to Sn by n. Hence its mean becomes n mu by n, so that it is equal to mu, and variance equal to n sigma square by n square. We can obtain variance of x bar equal to variance of Sn by n equal to 1 by n into n mu equal to mu, and variance of x bar equal to, this is expectation of x bar equal to expectation of Sn by n equal to 1 by n into expectation of Sn, which is equal to n mu equal to mu, and variance of x bar equal to variance of Sn by n equal to 1 by n square into variance of Sn equal to, what is it? N sigma square by n square equal to sigma square by n. And hence the large sample property is x bar follows normal with a mean mu and variance sigma square by n, okay, which is the sampling distribution of the sample mean x bar. And this is a large sample property, that is the population need not be normal for large n. And for all n, this sampling distribution of x bar is again normal with mean mu and variance sigma square by n for all n whenever we consider a random sample taken from normal mu sigma square, okay. That is, I have mentioned, that is, if x1, x2, etc., xn is a random sample taken from normal population. Let me write. If x1, x2, etc., xn is a random sample from n mu sigma square population, n mu sigma square population, okay, x bar follows normal mu sigma square by n for all n. For all n means whether it is a small sample or a large sample. That is, usually we consider a sample with size greater than or equal to say 30 as a large sample, and for size less than 30 is considered as a small sample. So that if x1, x2, etc., xn is a random sample taken from normal mu sigma square, that is from the normal population, for all n, this x bar is normal with mean mu and variance sigma square by n for all n. So that I have clearly given the idea about the distribution of the sample mean, the sampling distribution of the sample mean. And I have to mention the standard error of the sampling distribution, standard error. The standard deviation, standard error of the sampling distribution is the standard deviation of the sample statistic, that is equal to standard error equal to S equal to root of variance of t. If t is any statistic, root of variance of t is called the standard error. So that standard error of x bar is sigma by root n. Standard error of x bar is sigma by root n. Okay, the standard error plays a very important role in testing of hypothesis and in estimation of and in interval estimation, etc. 1 by standard error, the reciprocal of the standard error, gives the precision of the precision of the estimate. Okay, thank you very much.